Okay, it's great to be here. It's actually fantastic to take the stage after Max because he discussed something about innovation and about building blocks and the speed at which people need to go to be able to innovate. And this is very much one of those building blocks. Serverless is really much a buzzword lately. So I'm going to try to define a little bit with you what's serverless, and then we'll go into a deep dive. So I hope that it's not too technical, if depending on the audience. So I was told you guys are very technical, so I took a leap of faith and through quite many architectural diagrams, right? So I'm Adrian Hornsby. I'm technical evangelist for AWS, and I'm located in Espoo, actually, right? So we have offices in Helsinki and in Stockholm. And as you might have heard the news, we also getting a region by 2018 in Stockholm. So our presence in Nordic is growing, and hopefully this talk is going to help you a little bit as well understand some of the technology that AWS provides. So the agenda here, I'm going to go through some classic architectures, what we see with our customers. It's going to start from a classic web application down to in IoT, Internet of Things, and how you can design serverless applications, right? But before going there, I want to discuss a little bit about the term serverless. When we launched AWS in 2006, in fact, we launched serverless services. The first of them was S3, which was object storage service, right? So there's no servers under the hood for you to manage. It's very high level. You get an object and you store it in your data, in your storage, right? So the term serverless, in a way, is kind of weird because it's there till since 2006. But if you think about why it has become very popular lately, is because compute has become serverless, right? And this is something that was not available before. And when you have lots of databases, you have streaming services, you have storage, serverless, it's one thing. You can do pretty cool stuff. But once you have compute, then your speed of innovation goes dramatically higher and faster. And I think this is why serverless has become the buzzword it is today. And today I'm going to go through some architectures, and I'm going to focus a little bit more on the serverless using Lambda, AWS Lambda, which is in fact our serverless compute offering, right? So let's go a little bit there. So what are the characteristics of serverless, especially Lambda functions, right? Well, first, they are your unit of deployment. And whether you deploy one or millions, you deploy a function. And one function can scale up to one call up to a million calls. And you don't have to do anything on the architecture and on the infrastructure. Basically, we take that function, we deploy it in an environment, which will scale. We will take care of it. We will scale that environment for you, depending on the request and the number of requests that comes to it per second, right? So you don't have to worry about that. The second, or the third, because there was already two, but the third thing is, because you have a service, high-level service that is serverless and compute, we don't charge you for things that are not in use, right? So you deploy your function. When your function is not used, you basically don't pay, right? So that's a very interesting model. All of a sudden, you can deploy tons of function in your environment, and they only get activated, and you pay for it only when they are being used, right? So basically, you never pay for idle services, right? Even when you had auto-scaling groups, you always had one instance at least to provide the service, and that was something you had to pay. Now you don't have to do this anymore. And of course, you can say, right, serverless, you don't need to take care of the infrastructure, you don't need to patch your operating system, you don't need to do quite a lot of things, right? So basically, you skip the boring part, or at least what a lot of people call the boring part. I've been doing development for 15 years, and I've had my shares of managing databases at scale, and the day I could stop to do that, it was one of the best days of our lives, right? Because that's not the fun part. The fun part is how do we make application valuable for our business, right? It's not about how good we become at managing databases or infrastructure or operating system, it's how good can we make our application so that our business is here tomorrow. So some consideration before I go into architecture. Lambda, especially AWS Lambda, is stateless. And what do we mean by that is that when you deploy a function in the cloud, you should assume absolutely no affinity with the infrastructure, right? So you should always store a state of your function somewhere outside of the Lambda service. So, for example, in an Elastic Cache or caching system or DynamoDB or S3, somewhere that any other function could have access, right? Because there is absolutely no guarantee that your function will live in the same infrastructure the call after. So because we manage this, there is some requirements for us, and we need to make sure that you don't store state in that function. And in fact, it's very similar requirements what you would build anyway with microservices, right? If you want microservices to scale, the rule number one is to have stateless services so that you can kill any of those microservices and someone can catch up and start doing the things again because the state was somewhere else. You do have some access to storage, but you don't have access to anything else, so nothing related to the operating system. And that's beyond the life of your Lambda request. Things to consider also when you write a Lambda function, and actually I'm gonna ask the audience now, it's a bit late, but how many of you have already deployed or used Lambda functions? Okay, so that's very good. So for those that have never deployed or seen a Lambda function, is very similar to this. You have just a function, input parameter, and an output, right? So nothing different than what you would do. The only thing is that function does one thing and only that thing, right? So it's the idea of microservices pushed to the extreme. So two things that you need to consider a lot when you write your Lambda function is instantiate everything which is outside connection or connections to databases, to cache, or to other services outside the scope of your Lambda function. And there's few reasons for that. When we take your Lambda function and we deploy it inside the environment, we deploy a cluster of containers. It's containers, Linux containers that are baked by AWS. But those containers do share some resources, right? And they share resources. And because of that, you can and you should initiate your databases calls outside the scope of the function so that other functions might reuse that if they were sharing the same infrastructure, okay? The same way you would in any other microservices, make a call or initiate your database and your pool of database connection outside of the scope of the function so that when the function is called, the pool still exists from other functions. So you kind of reuse that pool for you. And you would do this outside of the connection, and you can also import all the libraries, outside libraries at the beginning the same ways as you would do initially. And those will be instantiated at the call start. So the first time your Lambda function is executed, we will import all the library in the environment, and after that, we will only call the Lambda function, right? So this is a very good way to let's say, prepare your Lambda function for a very optimal and fast use. Don't forget that you do have access to 512 meg of memory for each of your functions. The only thing you need to remember while using this is we do not guarantee that we will reuse that for you. So you will have it for the lifetime of, or the duration of the Lambda function, guaranteed, so at least 5 minutes. But after that, there's no guarantee that you can reuse that. So this temporary folder can be used to, for example, download images, download files, PDF, and do cool thing within this Lambda function execution time, and then you just forget about it. So this is a very simple way. That code, for example, is using FFmpeg to upload, take a video, put it into the temporary folder, and extract some frames, and then do some things with this frame, right? So the first pattern I want to discuss about is probably why it has become so popular lately, is really web applications. So as Max said, developers and people want to go fast. They want to have an idea and right away push it to production, to push it to prototyping, so that they can validate their idea as fast as possible with their customers. So web applications are very good for that. And it's very simple, and there are a few frameworks doing this even higher level, but under the hood, it looks pretty much like this. You would have your API gateway. An API gateway, for example, the Amazon API gateway, is simply a managed service that will maintain a consistent API across your Lambda function. If you have a Swagger file, if you can load that API into that Swagger file inside the API gateway to have your definition as a code, right? Very often it will be connecting to your Lambda functions, so you can have a Lambda functions for each of the resources of your API. You can have different Lambda functions for each of the verbs of your API, so you have very lots of flexibility there, right? And the classic way of doing that is to hook DynamoDB behind. So you would have API gateway, your Lambda function that does the compute, and then store the state outside to DynamoDB. And this is a very simple way to do dynamic requests. What you don't want to do in this architecture is handle the static using the static files using Lambda, because that's not what it's great at. You don't want to serve static files through Lambda. You want to do the computation and the kind of dynamic things. So what you do in this architecture is store your images, your video inside S3, right? Up there, and you put a CloudFront distribution in front of it. CloudFront is our CDN, Content Delivery Network, that will allow you to cache that content closer to your end user on the edge of the network, right? So that allows you to write web applications that go global in pretty much minutes. The next question would be, okay, how do you do security on that? The classic way is first to use bucket policies in S3, and then have the CDN configured for a bunch of things. For example, geo-restriction. If you want to serve only content to a particular region, you can do this from the CDN. You can use signed cookie and signed URLs to make sure that the content that is being accessed from S3 is legitimate, or that the request accessing the content is legitimate. And lastly, CDNs are particularly good for DDoS, right? Because you're pushing the DDoS attack out to the edge network, and there's edge network all over the world. So if you have a vector attack to your application, or to it's pushed to the edge, right? So having CloudFront for your static content is very good way to mitigate these kind of things. For the API gateway, you can use authentication. There is also a capability to throttle a cache, and you have usage plans. So for example, if you create a service using API gateway and you decide to expose this API in a marketplace, which you can now, you can have a usage plan. That means that you define customers of your API and tell them that they can use 1,000, 10,000, 1 million requests, and then they can be charged for that. So if you are interested in building services and exposing those services through an API and sell them to your customers, you can integrate those through the marketplace. All right? Of course, API Gateway and CloudFront both support certificates, so this is something you can do. And now API Gateway also supports the Amazon certificate, ACM, which it didn't before, so you can actually import your custom certificates as well. On Lambda side and DynamoDB, you can use something called IAM roles, right? So you have a full secure web application on serverless, right? If you're concerned about API gateway, so let me roll back. When you deploy an API gateway, under the hood, we deploy your CloudFront distribution for you, right? It's a default CloudFront distribution. The only problem is that currently you don't have access to make it the way you want. If you're really concerned about that, you can add on top of it another CloudFront distribution and have a WAF that will allow you to control a bit more your, especially to do SQL injection detection, all these kind of things, okay? So this is a way to do this. The only requirement, because you would have two CloudFront distribution on top of another, is first to use HTTPS, of course, but to disable the host header forwarding so that your CloudFront distribution can be piped together. So this is kind of a hack around the fact that you cannot really customize your API gateway CloudFront, but nonetheless, it's used a lot by the customers to serve application using serverless. If you want to do monitoring, you have a few options, of course, native to AWS, push all the logs from CloudFront and S3 down to a bucket, an outside bucket, and also monitor from the API point and the Lambda point your latency, for example, and invocation, especially the errors one, so that you can also detect and act upon that. Lambda now has a functionality called dead letter queue, in which you can push errors to be able to understand what happened, right? So kind of debug your errors in Lambda afterward. And finally, all those services are connected to CloudTrail, so using CloudTrail, you can actually audit any request that is done to the infrastructure of that architecture. When you want to, so the next question really often we get for this kind of three-tier web application is, okay, how do we manage this and deploy this? There's so many components. Well, recently we launched SAM, which is our serverless application model. And if you're familiar with CloudFormation, which is infrastructure as code, you can actually use SAM. It's a type of domain-specific language on top of CloudFormation to define your serverless application. So you would integrate your Lambda functions, your API definition using Swagger, for example, and things like this. And you can code and package your application using that. So under the hood, what it does, it creates a template, push it into S3, and then push that using CloudFormation. Okay. So that's the classic way. There's also a few other frameworks to do this. One very popular is the Serverless framework, which is not managed by AWS. It's a third-party one. And there is also, for any other language, like Sparta, which is a Go language supporting serverless web apps. So there's plenty of framework that allow you to deploy serverless application, especially web app, right? Recently, we also made quite some addition to API Gateway to make it even easier. So previously, API Gateway was quite difficult to, for example, act as a simple proxy. Now you can do these greedy variables like proxy, which catches everything, and then proxy that to your, for example, Node.js application or Express app, right? Some of the best practice you would want to do using API Gateway is having mock integration. So you can't have everything locally, so you need to use mock services to be able to debug and maintain that. If you want to access large data, especially video files through your API, the best way to do that is contact directly S3 using Cognito, for example, or use signed URLs, right? So you don't want to download or push or upload large files through an API gateway for a few reasons. It's because you have a timeout of 30 seconds, which is inherited from API Gateway. So you want to use and leverage S3 for that, and then you can do parallel uploads and multi-part as well. So that makes it a lot faster. And this is something which is very classic from our customers that they struggle with. And when they define an API or use API Gateway, they want to do everything through this API. But this is not something that we recommend, especially not for large files. Now, API Gateway does support recently binary files, so you can actually make request and return binary files like photos, but be aware of the size and the timeout. And use asynchronous calls if you have to go beyond that 30 seconds. Okay? The next pattern is batch processing, which is very popular for big data workloads. So the characteristic would be very large data set. You have enormous amount of data inside S3, and you want to periodically take that data and crunch the numbers, right? Typically, that's an ETL job or things like this. Very similar to what people use EMR or MapReduce for, which starts a lot of different parallel jobs, and then at the end, reduce all the results to get a final answer. The classical way of doing this is to have all your source of data pushed into an S3 bucket, which would be your row bucket. You notice here there is a row and staging bucket. This is also something which is really important. As a business, your data is gold. This is your money. So push all the row event into an S3 bucket and then keep it there. Don't delete it, especially not after transformation, right? Store the transformation again into another bucket, because every transformation you've done, you've paid for it, right? And maybe the transformation you do today is not the transformation you want to do tomorrow. And if you do transformation tomorrow and you don't have the historical data on, especially not the raw data because you've deleted it, you can't get some insight of your data that is in the past. So this is very important to separate those. And Lambda is used a lot in this architecture as an event trigger, right? So you push data into S3. S3 will create an event which is triggered by the upload of the file, and that will connect the Lambda functions to it. Lambda will detect the event that was pushed from S3 and act on it, right? So it's totally event-driven. If you don't push anything into S3, Lambda is never invoked. It's invoked as soon as you start to push things into S3. So this is really the classic event-driven architecture, right? And again, Lambda is then used also at the end of the stage to, for example, keep an index of what was being pushed and the result of the transformation of that data, for example. There's also an ongoing transformation loop there. It's because very often in those big data workloads, the data that you take as raw and you transform, you retransform it at several stages and then push it to different environment. So very often it's raw data that you transform into Parquet files, for example, to further process using EMR, for example, or Hadoop frameworks. The next thing is a splitter architecture. That means that it's very similar to the MapReduce. As I explained, this is classic MapReduce way of using Lambda function. Is you take initial input from a Lambda function and you split the request and the task to further down the stream Lambda functions. You want to do this, for example, if you have a large file being pushed into S3 and you take every 100K of that file and push it to a different Lambda function, right? So very efficient way to do that. Now you may ask, well, there's an EMR service, Hadoop framework to do this. And this is true. Now, these particular architectures are very, very popular for startups that don't have data scientists. Right? So this is pure Node.js programming. So every folks or developer that is very familiar with Node.js or Python can do that. Not everybody can start very complicated EMR, ETLs, and using Hadoop framework. So it's about where is the skill of your team, right? So that is actually very popular. It sounds weird to do MapReduce on top of Lambda functions, but it's extremely popular. The last Lambda function in that case is a reducer, and you see all the Lambda function would push the intermediate results inside DynamoDB to then be reduced at the end, mapped at the end. Some consideration, as I say, this is more for Lambda language type of people, so JS, Python. For your data scientist, I recommend EMR because you can do a lot more things with it. But if you just want to do a large file and split that into a small file into Node.js in 5 minutes, this is classic way. Right? Second thing is what we see very often is in big data workloads using Lambda, customers forget that a Lambda function has this power button. So you have your Lambda function can start from small memory to up to 1.5, so 128 megabyte to 1.5 gigs. And really consider that memory as a power button, because the more you increase the memory, the CPU and the networking associated with that Lambda function will be proportionally growing with the memory. Okay? So for example, a 256 meg function will have twice the CPU and network than a 120 meg Lambda function. So this is something which is very simple to do if your workloads all of a sudden start to slow down. We have actually have a reference architecture of doing MapReduce as well using Lambda. It's a bit different patterns, but they'll be on the slide so for you to check. The third pattern, and I need to go fast because I'm running a little bit late, is stream processing. This is the considerations are a bit different than batch, because batch time is not so important. Stream, you want results in real time, so it's or near real time. So you really very often you have spiky traffic and you want results fast. This is typical thing for example, on website when you would have click streams arriving and you want to, for example, do recommendation inside your web application for your end user, like doing article recommendations. For example, ULE does that, DNA does that, using stream, clickstream to optimize which article they want their end user to look at. Classical architectures for that is using Kinesis Stream, which is also a serverless thing. But what you do here is you actually hook it up with a Lambda function. And then you do very similar to what we do with MapReduce here, is that you store intermediate results inside an S3 bucket. So you aggregate inside Kinesis, store into S3, and then you have, for example, in that case, every 5 minutes, some Lambda function that is scheduled to take that 5 minute worth of data and do some processing, and then store the fully aggregated results inside an S3 bucket. And what you would have then is, for example, have Athena or QuickSight or some recommendation engine taking that data and acting upon it, right? You could do the same, a lot simpler, but again, it's about where your talent is. If you're good into JavaScript or if you're good into SQL, that will affect which architecture you want to use. In that case, we use a service called Kinesis Analytics that you put into 2 Kinesis stream, and then you can do aggregations of and calculation using SQL on that particular stream. So for example, in that case, you sample some measurement across a duration of 5 minutes in that case, I think, but across that stream. So you can do an aggregation inside Kinesis Analytics and push the results inside another stream to store into S3. Right? So these are very classical way of doing clickstream or real-time analysis of what's happening inside your, for example, sensors or web browser. So this is one way of doing it. So here in that case, you see the time window and the aggregation period. Right? This is also very classic way to do if you would use an API gateway. So In that case, then your web, you would have web clients that are using API calls to the web. So you wouldn't have the AWS SDK necessarily inside your application, but you can just attach your Kinesis processing behind an API gateway. In fact, API gateway as connector directly to Kinesis. So this is very simple to do. And it's a very good way of having a uniform API as well for your data processing pipeline. In that case, you see this is a customer that is using this to calculate impressions and click counts. And every time an article becomes very popular, they send notification to the journalist or also across the platform to give very fast feedbacks on what's popular, what's not, and then being able to react to, for example, further investigation, right? A couple of things you need to be very careful with is, of course, how you map your Lambda function to your Kinesis stream. A Kinesis is made of shard, and you would have one Lambda function for each Kinesis shard. So that means that the traffic that goes through the shards dictates as well how fast your Lambda function will execute. So this is something you need to be aware of, and you would have something like this when a Kinesis stream is pretty good. So this is the iterator age per milliseconds. This is how it would look like if your Kinesis stream is lacking behind. So if you see these kind of things, either you need to do something in your architecture, or especially increase your Lambda memory, or then make sure you're pushing as much as data or stack data inside your shards so that your Lambda function can take as much data to empty it as fast as possible. The fourth pattern, which is extremely popular, is particularly made popular by Netflix, is responding to alarm and event, which is for automation, right? Security, auditing, notification. Most of it is about extending the AWS functionality. Netflix has the concept of trust but verify. So they allow everything in their infrastructure to evolve by itself. But what they do is they use Lambda functions to catch all the event that happens in the infrastructure and verify. For example, if you would start an instance creates an event that it catched by an API, by the Lambda, that verifies if this image is consistent and conform to the security that Netflix wants to have. That will something that that is very often used as well is using Lambda to tag your resource as they start. Very often, people start resources, instances, or EBS volume, or things like this, and they are not tagged, which then further down the line makes it very difficult to know which part of the company as being using the service. So then you cannot apply billing to this particular business. This is a classical case of we have thousands of EBS volumes left. We have no clue where they are from, so nobody stops them, and then you pay for it, right? So use tagging and make sure that you actually have automated tagging, so for resource that has forgotten. And in that case, this tag in particular will put the owner of and the pre-simple ID of what started or made the API call, right? And then you would have DynamoDB to keep track of those tags so that you can then act upon there later on. Another very simple way of using Lambda functions for automation is a start and stop shutdown. Using a Lambda function that is scheduled, so very similar to a cron job. In that case, it's a serverless cron job using Lambda, and this is very simple. Every now and then, or in the morning at a certain time of the day, it will start at 8 o'clock, start all the instances that are required for a test environment, for staging environment, and then at 8 in the evening, we'll automatically shut down everything with a particular tag, for example, right? You can also hook SNS to it to send an email to the person that leaves instances in test and staging environment running all weekend, because it's money, right? If you leave your instances that are not used running all night, it's 60 to 70% waste, right? So it's a lot of things. Capital One used that exact principle of catching events from CloudWatch, CloudTrail, and to also do a policy and compliance to verify the policy and compliance of those rules. You can do cluster backup. That's another very simple way to do that. If you would use, for example, Redshift. Redshift has automated backups, but some customers want backups every 5-minute triggers. So that's a very classic way of doing it. Doing dynamic DNS for EC2 instance is also very classic for these kind of things. And I'm running out of time miserably. 5 minutes is fine for me. This is very important. It's called augmentation. And this is something that is very important. The classic use case is really augmenting something that you put, for example, in S3. Customers push a lot of content in S3, for example, videos or pictures. And if you want to create automatic thumbnailing or watermarking, this is the way to do it at almost no cost. Services to do that exist, but they are very pricey. So we see a lot of customers moving towards that. For example, having website and automatic thumbnailing, watermarking of files, or do transcoding or pre-processing, and also WAF updates. So they capture log, push into S3, verify or catch errors from those logs, and then update a WAF to make sure the security is up to what is happening pretty much in real time. Classic use case as well, Lambda is as a metadata index. So before last year, December, when we had reInvent, there was no way to have an index on S3. Now there is a beta program for that, but this was and is still one very classic use case of using Lambda to index what you're getting and pushing into S3. Each source data that you push into S3 creates an event that Lambda can catch, takes that metadata and push it into DynamoDB. What you would do then is use DynamoDB push change. It's the particular feature of DynamoDB that pushes changes inside the stream of everything that you put into DynamoDB. And then you can catch that from Lambda and push it into Elasticsearch, for example. So all of a sudden, you get S3 indexing and search functionality. In a way, this is very simple way to do a very advanced UI for your customers, and it's used, those two patterns, this one combined with this is used extensively for and by media companies, right? To serve and search content inside a website. The last pattern is IoT action. IoT is a service that we have for Internet of Things. And when you push data inside the IoT, you can apply rules and action. It's basically a rule engine. So we take your data that you push inside IoT, and we can apply some actions to it. Each action, in fact, is a Lambda function. And this is used very often by companies to do predictive maintenance. So in that case, in that particular case, it's a customer that has very large wind turbine, and they send in real-time traffic inside IoT, and they have a function inside Lambda that calculates the standard deviation of vibration. And as soon as vibration goes above a threshold, they stop everything down. They stop the engine because they don't want to pay millions of dollars for something for maintenance that has to be done. So this is classic use case of using Lambda for predictive maintenance. And in fact, this pattern is used all over the place in IoT to control your devices in the environment. On that note, I just want to leave you an idea. Serverless is great, allows you to innovate very fast. As said, Max, innovation is the key for businesses, and serverless is the sweet spot for that. Now it's not the hammer, so before using Lambda for everything, make sure it fits the proper use case, make sure that it does and the requirements and the specificity of Lambda does and complies to your requirements, because otherwise it's gonna be another game of hammering and trying to do everything with Lambda, which is not necessarily the best. All right, thank you very much.
Yeah. So thank you, Adrian, for the most information-packed presentation today, at least out of the ones that I have seen. So unfortunately, we don't have time for questions to Adrian right now, but you will be here after this presentation available here, or if you want to discuss with Adrian, I guess you will be here for a bit of time, so you could also go into the one-on-one area behind the curtains there. So
there's my Twitter handle and my email as well. @horn is my Twitter, @horn@amazon.com. Feel free to send a message. Yeah.
Exactly. So please approach Adrian here if you have something burning on your mind. But big thanks. And now we have a 10 minutes break. So thank you all, and we'll continue in 10.